Hello everyone, this is Chandrasekhar here. Welcome to my Kubernetes Zero to Hero session. First of all, thank you everyone for watching my last video. In today's session, I'll talk about control plane, data plane, worker nodes, kubelet, container runtime, pod, how a pod gets created or how it gets deleted, and then we will complete the request flow in Kubernetes. By the end of the session, you all will understand everything which is here. Everything which is a part of this will be explained in this session. So now let's start with a very basic and small question. We all know that Kubernetes contains API server, etcd, scheduler, and controller manager. But what we still don't understand is where does my application actually run? When I say Kubernetes runs application, where exactly those application run? What we think is applications are running on containers, but that is not right. Kubernetes does not manage containers directly. What Kubernetes manages pods. Today, in our session, we will understand how Kubernetes actually runs application. Let's think about the current state of our Kubernetes setup. In order to understand, we will execute a command like the way we learned in our last session, Kubernetes get nodes, and it gives me output that this is a single node which is running. As of now, we have this. We know Kubernetes has a control plane, but where does our application actually run? It doesn't run on control plane. Application runs on worker nodes. It runs on data plane, but we currently have only one single node cluster. So the first thing which we will do today is we will create a multi-node cluster and see how Kubernetes behaves in a real world setup. In order to create a multi-node setup, I have uploaded certain files in our GitHub repository. You go to commands folder, within that kind commands folder, within that manifests, and this file contains the details which is needed for you to create a multi-node cluster. Also, you have to execute some command. That command is present in commands.md file. Click on this file, and this is the command which you need to execute to create a multi-node cluster. I'm just copying this command and I'll execute this command here. So here, I'll first go to this specific path, and at this specific path, I'll execute that command. So this is the path. Now I'm going to execute this command. I'm copying this command now, and let's execute the command here. As I execute this, within few minutes, the multi-node cluster setup will be ready. So our multi-node Kubernetes cluster is ready. Let's execute the command. Few minutes back, when I executed Kubernetes kubectl get nodes, it just said me that I do have one single node present. Let's execute it now. Kubectl get nodes. And as I execute this command, it says that I do have three node. One node acts as control plane and remaining two acts as worker node. So now what is the architecture currently? The architecture currently can be drawn quite in this way. It is having a control plane. It is having the first thing which it's having is control plane. And this control plane will definitely have API server. It will have scheduler, etcd, and controller manager. So this will be the part of control plane, like the way we learned in our last session also. Now another thing which it is having, which we learned in this session is we have created another plane to which we call as data plane also. What data plane contains now? Data plane contained two different nodes, worker node 1 and worker node 2. These are the two nodes present. And in these two worker nodes, we will have pods running. We did not create the pods yet, but we will, in few minutes, we will learn how to create pod also in these worker nodes. So like the way we learned in our previous session also, control plane makes all the decisions. Where should apps run? How many pods should run? What should happen if a pod crashes? All the decisions are made by control plane only. Data plane executes those decisions. For example, data plane runs containers. Data plane ensures that proper CPU, memory, and all the user requests are served properly. A very simple rule, if you can think about, control plane makes decision, it thinks, and data plane actually implements the decision which is made by control plane. It does all the work. Now let's explore nodes a bit and let's try to understand a bit more on all the nodes which is present. So now if I put -o wide, which we learned in our last session also, it gives me all details about each of the node which is present. More details about each of the node is present here. In case if you want to see more details about each of the node, then there is another command which Kubernetes offers, which is kubectl describe node. So now let's see more details about one of the node, kubectl describe node, and give the name of the node. All these commands are present there in Kubernetes commands folder in GitHub. You can refer that. So kubectl describe node and the name of the node. As you hit enter, it gives me plenty of details which is very much needed to understand for a node. It gives me the details about capacity. It gives me the details about allocatable memory. It gives me the details about system info. Gives me that in under allocatable memory, under allocatable resources, there are 22 CPUs available. Under capacity, 22 CPU. That basically means no CPU utilization is 0% at this point of time. Everything can be allocated. So you can see plenty of details about the node by executing kubectl describe node command. This is the command which you can execute for that purpose to see more details about nodes. These are very important commands used highly to troubleshoot any of the failures which you get in Kubernetes. Think about some real world example. Suppose you have two nodes, like the way we do have two nodes, worker node A and worker node B. For example, CPU utilization in worker node A is 90% and CPU utilization in worker node B is 10%. Where should a new pod run? In case if you are thinking to create a new pod, where will it be running? Certainly it will be running in worker node B only. Why? Because in worker node B, we do have more available resources. And now let's try to understand how to create a pod. What command you will execute to create a pod. So Kubernetes offers a command to create a pod, and that command is kubectl run and give the name of the pod. For example, I'm giving the name of the pod as NGINX pod, and then you give hyphen image, and then you give the name of the image. For example, I'm using the image as NGINX. I'll explain about from where these images are getting pulled and all in few minutes. So now as I have executed kubectl run and gave the name of the pod, and the name of the pod which I gave as nginx pod, you can give any random name which you can think about, and hyphen image and the name of the image which you want to use to create the pod. As I hit enter, it will end up creating a pod for me. It says that, okay, fine, I have created a pod for you. So now if you want to see whether the pod is created or not, there is a command which Kubernetes offers, which is kubectl get pods, and it says yes, a pod which is with the name nginx pod 1 is created. It is creating the container. Now let's try to understand what happened at the backend when you executed this command. And it is very important for you to understand the flow. You have executed the command. As you executed the command, kubectl picked your command and passed your command to API server. Like the way we learned in our last session also, API server is the front end of Kubernetes. Every request enters to Kubernetes through API server only. API server understands the request that user wants to create an Nginx pod, and here you go, you have your pod ready. Now, even before the pod gets created, API server consults with etcd like the way we saw in our last session also. So I won't create the flow diagram for that. The flow diagram I've already created in last sessions. So any of the viewer who is watching it for the first time, in previous session, I've created the flow diagram on how instruction passes from API server to etcd to scheduler to controller manager. Please refer that. I'll put previous session link also in my description. So now etcd stores the request and etcd checks in its database where it stores pod related information, node related information, deployment related information, services, config maps, secrets related information. So if API server is the brain, etcd is the memory of that brain. Without etcd, Kubernetes forgets everything. So now once etcd confirms that there are no pod present, which is with the name nginx pod, scheduler picks up a node. Scheduler do have two worker nodes to pick, worker node 1, worker node 2, there are certain criteria based on which scheduler picks up the node. Scheduler checks for available CPU, available memory, node health, and maybe there are certain scheduling rules based on which scheduler decides which node to pick. Scheduler finds, okay, fine, out of worker node 1 or worker node 2, worker node 2 is the good one based on its memory, available memory, based on its available CPU. Worker node 2 is best, and it then passes the information to execute the to create the pod in worker node 2. So now scheduler does that specific job to decide which node to choose where pod will be created. Now pod is created. As of now, when you executed this command, you do not understand where and which node pod is running. There is a command which we can use, which we can execute to get the information about the node where pod is running, and that is kubectl get pods hyphen o wide. As you execute this, you get to know that the pod is running in multi-node worker 2, and this is all at a random. This pod is running in worker node because scheduler decided, okay, fine, worker node 2 do have sufficient capacity resources for this pod to run. There is no explicit instruction which is given. All at a random, scheduler has chosen this specific pod. Now, what happens next when scheduler decided to choose this specific pod to create this specific node to create the pod? What happens next? Now, there is a very important component which is present in each of the worker node, to which we call as kubelet. This let's draw. So there is an important component which is present in each specific node, to which we call as kubelet. So worker node, this worker node, which is a part of data plane, will have a very important component present, to which we call as kubelet. What this kubelet does? This kubelet, think of this kubelet as a node agent or a supervisor, or think it of as a local manager. Control plane says, hey worker 2, run NGINX. Kubelet responds, okay, I will do it. Now kubelet constantly checks with API server asking, is there any work for me? Now think it of a real example. Imagine of a company which is having a CEO, manager, employees, and so many other verticals. CEO decides, okay, fine, I have to build a house. Manager coordinates and workers performs the work. In Kubernetes, control plane passes instruction to kubelet and container runtime executes all the instruction. Now, we all think that Kubernetes runs container, but that is absolutely a wrong thought. Kubernetes doesn't run container. Kubernetes just manages execution of container. Container runtime runs container. So container runtime is like a software, is a separate software which is used to run the container, which gets configured, which gets installed as we do Kubernetes setup. So now there are different examples of container runtime, container D, CRIO. So there are various container runtime. This is a separate software. There are runtime. So they are of different types. There are container D, there are CRIO. Different types of container runtimes are present. Usually, since we are using kind uses container D as the container runtime. So what are the different responsibilities of container runtime? Container runtime performs various tasks. So various responsibilities of container runtime includes pulling of images. It pulls images from the image registry. It starts container, stops container. It does multiple job. This is the responsibility of container runtime includes starting a container, stopping a container, stopping a container. Also, it manages container lifecycle as well. So container, it's the container runtime which ensures that container starting, stopping, entire life cycle, everything is managed by container D or the container runtime only. There could be multiple differentiation in between container D and CRIO, which we will talk about in our upcoming sessions as well. So now we have nodes, we have pods, which is created. Now, if you want to know which container runtime your node has, then you can execute the command, or since we already executed the command above for to describe the node, in this output itself, you will be able to find the container runtime, and you will be able to see the container runtime version which is present. You can see the container runtime version is container D 2.2.0. This is the software which actually runs container for you. So what is the complete flow? Kubelet passes instruction, and consider this as a kind of summary also what we have learned till now. You have passed the instruction. Let's draw it a bit. So what you have done, you have passed the instruction. As you have passed the instruction, instruction is picked by kubectl. That is the first thing which happened. Kubectl picked up the instruction. Kubectl later passed that instruction to API server. API server passed that instruction to etcd. Etcd passed that instruction to scheduler. Now what scheduler did? Scheduler selected the worker which is present in data plane. Scheduler selected the worker which is present in data plane worker 2. It went to kubelet. Kubelet called up container D. Since we are creating by using kind, it will be container D. And this container D created containers or pods for us. So everything is done. This is the flow which we have followed till now. This is the flow which we have followed till now. So this is what we have done till now. So now let's understand quickly. So this is what the entire flow. Now we'll spend some time in understanding what a pod is. So basically in Kubernetes, pod is the smallest unit which you will be creating. So consider that container is a person and pod is the apartment where that person lives. And what is the node in that context? Node is the apartment building where they can have multiple apartments. So within a node, we can have multiple pods, and within a pod, we can have one or more than one container. So pod is the basic building unit which is present within a Kubernetes. A pod can have one or more than one container. It can have container A, it can have container B, container B, it can have one or more than one containers present within it. Now, you can we have created a pod at this point, which is with the name in NGINX. We can describe the pod also, like the way we have described node, we can describe pod as well. So in order to describe the pod, the command which Kubernetes offers is very similar the way we executed for node. Kubectl describe pod and give the name of the pod, which is this, which is this. So now as I execute this, it gives me all details which you need to know about the pod. It gave me the container detail, conditions, volumes, all the events which has happened. It gives me pod IP and all necessary details which you need to know about the pod. But the question remains same. Who selected the node? It's scheduler who selected the node. So now you know about nodes, you know about pod. We have created our first pod also by execution of command, which is kubectl run command to create the pod. But going forward, we will also learn how to create pod by execution of certain manifests. What are manifests? Manifest is nothing but a YAML file which contains all instructions which you want to be present within a pod. Everything, all details, image details, and every information which you want to pass within a pod is kept within a file which is written in YAML format. Even the pod which we have created, we can see YAML of that pod also. So in order to see that, let's execute a command kubectl get pod, and then we will say the name of the pod, kubectl get pod, and say name of the pod and nginx hyphen pod, and then you say hyphen o YAML. And as I hit enter, it gives me all the instructions which I want to pass within a pod. This is very detailed. When we are writing, we won't put so much of detail within the pod. But just to highlight, it contains kind, which is the object type pod, specification container, which is of the image nginx, and few other details. This is like the way I said, this is too detailed. While we are creating, we won't pass these details because it's not needed. So now you have created a pod. You now know how to detail the content within a pod. Now you also know how to see the details within the pod. One very important thing which you need to understand is what are the various statuses your pod could have. Let's create a pod which is of failing status. So I'll create one more pod and I'll give the name of the pod as bad pod. And for this, I'll use the image name as nginx common, some invalid tag I will use for the pod, and it says a pod which is with the name bad pod created. And now if I execute the command kubectl get pods, you see what it says, bad pod status is error image pull. So there are multiple statuses which your pod could have. It could be in running state, it could be in pending state, it could be in error image pull state. Various failures could be seen within the pod. We will talk about those also in our upcoming session. Now, a very, very important thing which you need to understand is you can even delete the pod. Now let's try to delete the pod. Kubectl, let's try to delete the pod which is in running state as of now. In order to delete the pod, the command will be kubectl delete pod and give the name of the pod. And as you have deleted the pod, as you have executed this command, the pod which is running is deleted. Now, can you afford this kind of situation when you are working in production environment? No, you will not be able to afford this kind of situation. This will be a big mistake which you can do when you are in production environment. Understand, pods are ephemeral in nature. Pods can die, can create very soon. So there should be someone who should work on auto healing of such pod in such situations. And that is where some more higher objects in Kubernetes comes, like replica set deployments, which we will talk about in our upcoming session. So what we learned in our today's session, we learned everything which you need to know about data plane. You learned about container runtime, which is container D, CRIO. You understood how to create your first pod. You understood what happens when you use some invalid image and the status of the pod. You also learned how to delete a pod. In my next session, I'll talk about some more higher objects. Thank you everyone for watching this session. If you did not subscribe my channel, please subscribe it so that you remain updated about my upcoming videos. Please share it with others also so that even others gets benefited. Thank you everyone.